Okay, continuing with number 12. They talk about the area of a sector, so right away I know to use this formula. 1/2 radius squared theta times theta. Don't forget theta has to be in radians. The information that they provide is 8 feet for the radius. And let's see, the next number that they give for number 12 is the area is 25. Square feet. And then the theta is what we don't know. So this is 1/2. 8 squared is 64. You're squaring the unit as well. The theta is here. 1/2 of 64 is 32 times theta. And then you have 25 feet squared over here for area. You're isolating for theta. Right now this theta is being multiplied by the 32, so you're going to divide it right off of the theta. Likewise on the other side. So theta ends up being, these units cancel, this is gone. They said around to 2 decimal places, so 25 divided by 32 is 0.78125. So to 2 decimal places, it would be 0.78. And it has no units because it's theta in radians. Okay, problem 13. In 13, object is traveling around a circle with a radius of 10. If in 20 seconds a central angle of 1/3 radians is swept out, one is the linear speed. Okay, formula for linear speed is radius times the angular speed, which is the theta over t. Okay, again, the radius that they've given you here is 10 centimeters. And then it says, if in 20 seconds, that's the unit of time, a central angle of 1/3 radian, this is the central angle here, and it has to be in radians, and it is. So 1/3 radians, radians means it's decimal and has no unit, or it's a pi type number. This actually is a decimal if you converted it. And it takes 20 seconds to go this far around the circle. Okay, so now it's top times top. Divided by 20. And you can go ahead and put that in your calculator. 10/3 divided by 20 is 0.1666, and it actually doesn't say what to round to, so I'm going to round to the hundredths place. The units are centimeters on the top per second. So this is an approximate answer to the hundredths place. When it doesn't say where to round to, you can just ask me. If you were going to give an exact answer, this is only approximate, and I went to the hundredths place. If you want to give an exact answer, be careful to look for those words in the directions. Now, it didn't ask you to give an exact answer here. It didn't specify. But just to go over the arithmetic, just to practice the arithmetic with you, you would go top divided by bottom. But when you're dealing with fractions and you're doing division, it's the same thing as multiplying by the divisor. multiplying by the reciprocal of the divisor. So it'd be like that. It'd still be in centimeters per second. And then you would go top times top, bottom times bottom, and you would get 1/6, which is equivalent to the 0.16666 that you saw that I rounded off. Okay, problem number 14. Okay, in 14, a wheel of radius 4.2 is moving forward at 12 feet per second. How fast is the wheel rotating? The word rotating refers to the theta. So actually what you've been given with the 12 feet per second is the linear speed. So here's the unit. The formula rather, linear speed is radius times theta over t, as I used in the last problem. Okay, and so then the 12 feet per second goes right here. The radius that they gave you in this problem is 4.2. And when they ask you how fast is the wheel rotating, you're actually solving for this angular speed. How fast it's rotating in terms of a central angle in radians per unit of time. So it's as if you're solving as just this as one unknown. You're going to divide by 4.2 on both sides. Cancels. So this will give you an answer of how many radians per unit, per second actually, since that's the unit of time that this object is rotating. So 12 divided by 4.2 is 2.857, and the directions say, let's see, no indication of where to round. I'm going to round it to the 10th place. And you can always ask me if it doesn't say. And maybe we'll just make an agreement when we're actually taking the test that for any directions that don't say what place to round it to, perhaps we'll do all of them to the 10th place or the 100th place for the ones that they don't specify. But we'll talk about that on the day of the test. So if I go to the 10th place, it's 2.9 units per second. Okay, number 15. The wheel's rotating at 6 radians per second, since the radians would be the theta. A wheel has 27-inch diameter. To the nearest foot per minute, what is the velocity? We'll start off with this, times theta over t. Okay, the radius is, let's see, 27-inch diameter, so 27 is 13.5 inches for the actual radius because they gave you the diameter. And the theta per unit of time is the 6 radians per second. And then it says, what is the velocity to the nearest foot per minute? So we're going to be in inches per second, and then we're going to have to convert it. Let's just get this answer first. So 13.5 times 6 is 81. Inches is on the top, seconds is on the bottom. inches per second. So that's the answer with the units that you were given in the problem. Now, if you want to go for an answer that's in feet per minute, first, why don't we try and change inches into feet? So if I want inches to go away, you're converting from one unit to another. I want inches to go away. That same unit has to appear here, so that it'll cancel with this. I'm trying to go into the unit of feet. There are 12 inches in 1 foot. That'll get rid of the inches. Then also, I don't want seconds. I want minutes. So we want to get rid of seconds. So put another conversion box here. If seconds is in the denominator, it needs to appear in the numerator if you want that unit to cancel. And we're going into minutes. There are 60 seconds in 1 minute. So seconds will be gone, and the units that will remain are feet per minute. And now we're going to calculate 81 times 60, which is 4860 divided by 12. The answer is 405 feet per minute. Okay, problem number 16. And number 16, a weight hangs on a rope that's 20 feet long. It swings through an angle. Okay, so it's like you have a rope here. Let's say there's an object and it swings. And then ends up right here. And it says that from a rope that's 20 feet long. So this is 20 feet. And if this picture was enclosed in a circle, this would be the radius. Swings through an angle of 27 degrees. That means that's your central angle right there. But again, central angles that are in degrees are not acceptable. You're going to have to change them to radians in any of the formulas that you're using. How far does the weight travel each second? Round to the nearest 0.1 foot. Okay, so how far does it travel each second? So we're doing linear velocity again. And in here is your angular velocity. So the radius is in 20 feet. And then the theta for every 1 second. You can put the 1 there if you want to or not. You can just put seconds. And I would put the 27 degrees in there, but it needs to be in radians. So I'm going to go 27 degrees, convert this to radians by going 180 is equivalent to pi. Let's get that in decimal form. So 27 times pi divided by 180 is 0.47123. Or actually 124 if I round it off. But now it's in radians. Okay, so right now I'm going to be in feet per second. So times 20. And the unit that we're supposed to be in is how far does the weight travel each second? Okay, so we can leave the feet in there, and they want us to round to the nearest 0.1 units, nearest tenths. So this is going to be 9.4 feet per second. And that is 14 through 16.